So I hope we are good to go. We'll start with the Linux overview, permissions, directory structure, and Linux commands. So what is Linux? Linux basically is a family of open source operating systems, like Unix-based operating system, which is based on Linux kernel. And the predominant advantage of Linux is that it is free and open source software. We don't want to give a particular price tag to purchase a key or anything. We can just download it from internet and we can just install it and use it. That is the main advantage of Linux, and it was initially released in 1991 by Linus Torvalds. And as of now, Linux, we can see Linux everywhere in different flavors and different distributions. It is found in servers, of course, in supercomputers, and we know most of the servers comes with Red Hat, Linux, and secured Linux, etc., rather than other operating systems. So in servers, Linux have the upper hand, and Linux is predominantly used in controls, car consoles. So we can find Linux everywhere as of now. So, and the biggest success and advantage of Linux is Android operating system. The Android operating system is developed on top of the Linux kernel, and there are some rumors coming like that Windows is moving into Linux kernel. We have to see and wait and watch what's going to happen with Windows. But there are some rumors like that and some blogs saying that the next versions of Windows operating system is coming with Linux kernel. I'm not sure about the authenticity, but if that comes, then again there will be a success for Linux. And as I mentioned, Linux comes basically as distributions or distros. It means an operating system that is made up of a collection of softwares, and the commonly used distro is Ubuntu, and on enterprise level, the commonly used distro is Red Hat Enterprise Linux, which is RHEL. And there are other flavors like Fedora, CentOS, and it is highly flexible. Even we can develop our own Linux distribution. So even we know the government organizations have their own Linux distributions, like India government as well as Kerala government have their own Linux distros known as BOS kind of thing. So it is highly configurable, and we can develop our own Linux distro. So that is the major advantage and the overview on Linux. So we should know why we want to use a Linux system. That is why that is the predominant agenda of this session. Linux basically is a free and open source system. And as I mentioned, it is fully customizable because even from the UI to the security level, we can customize it according to our own wish. And as I mentioned, there are large distros of Linux that is being used by the government organizations, the self-developed distributions. And I was also once a part of for a particular distro for one of the government organization. So, and the predominant and main thing why we want to use Linux is because of its high stability, because majority of us are like hardcore Windows users, and we are using Windows system for more than 2 decades or 1.5 decades. So we have seen Windows getting crashed, and while we are using Windows systems, so at some point of time, it will just go onto a blank screen and showing that some error occurred at particular address 0x0010, something like that, and it is going into a blue screen of death. And again, it will be rebooting, and it will be just coming into a bootloader screen, and it won't boot up from there. So we want to again call the computer person, or we want to again put the CD or pen drive, and we have to again boot it, and we will lose all the contents of softwares which were the part of C drive. So these all are the issues which are not yet addressed by Windows about the Windows operating system. But the major advantage of Linux or Linux distros is that it hardly crashes. I have been using Linux for more than 8-9 years, and in my lifetime, I haven't seen such a scenario where the Linux actually crashes. So the major advantage of the Linux lies that it is highly stable and it hardly crashes. And comparing to security, Linux, I should say it's more secure. I won't say it's a foolproof secure, but it's more secure because it is supported by large community. As I mentioned, it is open source, and anyone, a programmer or a security architect or a security researcher can go on and get the source code, and they can review it. And if they are finding out any vulnerabilities, they can easily patch it, and they can push the patch. So basically, it is supported by a very large community. So basically, Linux is more secure when compared to Windows. So that's about the overview and why we want to use Linux. Next, we are moving on to the components of Linux system. So basically, as every operating system, Linux is also divided into 2 components: the user space component as well as the kernel space component. In between, if you are having any doubt, you can ask, right? Okay. Please interrupt me and go on and ask doubts. Okay. Yeah. So we are moving on to the components of Linux. Basically, it have 2 components: the user space as well as the kernel space. And user space, as the name indicates, it's the thing that which we see, the user sees. And the kernel space is the space where everything is made happen for the user space to work. So again, the user space is divided into two, the system library and the system utility. So what is system utility? System utilities are the applications that we use. The documents, the video players, the MP3 players, everything comes under system utilities. And system libraries in Linux is a set of C code, and it is known as libc. It is actually a wrapper function to make the things happens for kernel. So system libraries is a set of C code which is used to transfer the each and every code from the user space to the kernel space. So basically libc works as a wrapper function, and it transfers the calls from kernel user space to kernel space. So that is a very broad view on what is a Linux system. So we will be seeing more deeper about this Linux system in the coming slides in the second part of this session. So I hope that is very clear to everyone. If you have any doubt, just go on and ask, okay? So we can move on to the directory structure of Linux. So Linux starts from the root directory, and it have several intermediary directories such as bin, boot, dev, and a lot of like temp, bus, bin. So each directory have a particular function to do. The bin directory actually it is used to store the command binaries, the system command binaries. Like boot is used to load the static files of the bootloader. Then host specific system configuration files such as etc directory is there. Then of course the home directory to store the the libc files, the basic C code for the library is stored in like lib directory. And for system binaries, there is sbin. To mounting a removable media, there is media directory. And the predominant thing in this is the final one, the proc file system, which is actually a file system that does not exist, but it do exist. It's a virtual file system. Whenever a process is being executed in Linux system, a corresponding entry will be created in the proc file system, and based on that entry only the whole process works, and we can trace and we can see what all are the things that is going on while running a process. So that is why a proc file system is being there, and whenever the process is being killed or terminated, that entry will be terminated from the proc directory. So that is basically the directory structure and directory overview of the Linux. So these are some of the most useful Linux commands. I think everyone will be aware about this. First one is the pwd to find out the current directory or the current directory where we are now, and ls is to list the files in a particular directory, and ls command can be utilized in several ways to find out the artifacts of a particular files also. cd is used to for changing the directory. mkdir definitely for creating a new directory. Mount to mount a particular file system or something like that. And these are the navigating file system commands, some basic commands. And next I will move on to some manipulating system commands like uname. I think this you have to explore more the uname command, because uname command gives us an entire idea about your operating system, the version of the kernel which it is running, and everything about your operating system. So I just recommend you to play around with this uname command. Then ps to find out the currently running process. Kill, as the name indicates, it is used to kill the process that have been running. Service, it's used to find out the background as well as the foreground running services. And shutdown, as the name indicates, it is used to shut down the entire PC or entire system. So these are some of the basic commands to take care of your file, which is cat, dd, cp, etc. Cat is used to output the contents of a particular file. dd is used to for converting and copying a file into a particular format. Then cp is for copying, mb for moving, and cmb for comparing. And the final set is like some funny Linux commands which you have to play around. Like cal stands for calendar. We will get an inbuilt calendar from the Linux terminal. Then history, which is used to find out the entire history of the activities that we made in through the terminal console. Then fortune and s, just play around with it. It's very funny to play around with fortune and s command. And rev, as the name indicates, it's a reverse command. I think we all have been very much irritated about reversing a file in our college days or in school days. But Linux give an inbuilt solution. If we are inputting say rev and input file name, so that is the format. And if you are putting it, it will give us the reversed content of the file. So these are all the basic Linux command. So just play around it if you are newbies to Linux. Otherwise, it's okay. So now we can move on to Linux users and group permissions. So when we are talking about Linux, we can't actually skip this topic, the Linux users and group permission. It has the ability to multitask, because every operating system is designed in such a way to multitask. But every operating system is not designed for multiple users at the same time. So that makes Linux peculiar, because Linux has the ability to have multiple users to play around and to access a particular file at the same time. So there will be a question arising how these users are protected and how the permissions of that files are protected. So the answer is Linux users and group permissions. Linux users are basically divided into three: user, group, and others. And what is permission? Permission is the right to act on a particular file for an user. So each user will be associated with a set of permissions. So we will be seeing more about it. So example C. In this slide, we can see this is a screenshot from my system. So I have been checking a.txt. I have created a file a.txt, and I have been checking the permissions for a.txt. So in this, we can see that -rw kind of thing. So the first three bits, the -rw bit indicates, and dash indicates it is the user permissions, and the rest, the other three indicates the group permission, and the last three indicates the others permissions. So basically, what is the first dash? Here it is a regular file, so dash indicates that it is a regular file. So suppose if it is a directory, then instead of dash it will be D, or if it's a link file, then it will be L. So keeping it apart, the user here for this particular file is having read and write permission, and the user neither group or others is having not having a execute permission, because it is not an executable file, it's just a text file. So that's why it is missing. So here the user is having the read and write permission, group is having the read and write permission, as well as others is having only the read permission. And we can see here each bit, actually each read, write, and execute bit, actually it diverts your particular values, and it is associated with a particular, as you know, it's a bit actually to be set, and each bit is associated with a particular values. That is what I was mentioning here. The read is associated with a value 4, and write with 2, and execute permission with value 1. So altogether a user or a group will be having a total permission set of 7, a value 7, means 4 for read, 2 for write, and 1 for execute. So that is about Linux users and group permissions. And some of you might be wondering why I have skipped some special permissions. As of course Linux have some special permission bits that we will be going through in the next sessions, in the coming slides. Okay, so I hope it's clear for everyone. If you have any doubt, just keep on asking. Okay, so now we can move on to the Linux security architectures and access control, how a system call works, and what all are the security modules of Linux. Okay, so moving on to the access control mechanism, Linux actually inherits the core Unix security model, which is the discretionary access control mechanism. And most of the flavors of operating system uses discretionary access control mechanism only. So what is an access control mechanism? So we can just define it in this way. So if you want to watch a movie in a movie theater, in a film theater, then you should get a ticket initially. So there are different platforms to buy a ticket, like you will be booking it through Book My Show ticket, or you might be going to the film theater itself and taking the ticket from there. So getting a ticket means you are just an authentified user to watch that. Doesn't mean you that movie unless until you show that ticket to the, so at the security check-in they have to scan that ticket, or they have to tear that ticket, and then only you will be allowed to enter. So that is actually access control mechanism. Means you have to be verified. You have to be a verified user for accessing a particular resource or a particular objects or a particular files or a particular process in a system. So basically, access control is for granting or withholding the access to your resource. So this access control mechanism is commonly relations between file and user characteristics. And predominantly, there are two types of access control mechanism, which is DAC and MAC, discretionary access control and mandatory access control mechanisms. So we can just move on through the basics of the DAC and MAC. So what is discretionary access control system? So say for example, if I am creating a file or you are creating a file, then you are the owner of the file, and you have to specify what accesses it should have to other users. So that is basically discretionary access control mechanism. Means it is out of the discretion of the user or the owner who creates that particular file. So the control of access is based on the discretion of the owner and discretion and power of the owner. So as I mentioned, when I create a file, I decide what access privilege I want to give to other users who are accessing those files. And most flavors of the operating system like Windows, Linux, Mac, Linux, most of the flavors, Macintosh uses DAC-based models. Model have some pitfalls and shortcomings that we are going to see. So I have just provided an image of DAC here for your understanding. So the owner creates the object as well as owner specifies the users and groups who can access that particular object. So what is the issue with the DAC model? So an application or a process running as a user means applications in Linux which are given a predefined root access. Like ping utilities kind of thing, ping command, they are given by default root privileges. So for such an application, if is there, then the application will be running with the user's permissions. Means it doesn't want an elevated privilege because it already have an elevated privileges to access file socket. So in that case, if that particular utility is being abused, then a complete system takeover can happen. So such a scenario should not happen. So we want to categorize the users as well as we want to categorize the resources as well as the functions of the operating system. So we need a better model. So we can discuss about that model that is known as the mandatory access control model. So other issues with the discretionary access control mechanisms are low level of data protection as well as obscure, because there is no centralized access management. Just it is out of the discretion of the owner. So it is not done by a system or by a policy. So that is the major pitfalls with the discretionary access control model. So this is how actually the pitfalls of DAC is being overcome using mandatory access control mechanism. And some flavors of the Linux such as RHEL, CentOS, Fedora, everything comes out with mandatory access control policies with SC Linux enabled. So we will see that in detail in the coming slide. So what is basically mandatory access control? Here the system specifies which process want to access which data. It is not out of the discretion of the owner. So it is a system who decides. So how the system decides? So each subject and object means each process and results will be associated with a particular security level. For example, one process will be given a particular security classification like top secret. Another process will be given a security classification like secret. Similarly, object will be also provided. Means the files or the other devices which are attached to the computer will be provided with a particular security clearance level like the top secret, secret, confidential, classified. So as the figure indicates, if a secret level clearance level subject is accessing a top secret object level, means accessing a file, then it will be denied by default because the security clearance has to match. So a secret security clearance services or the or a subject can only access a secret or a below secret level, below security level operations. So that is basically about mandatory access control. So as I mentioned, subjects are given a particular security clearance like top secret, secret, and data objects means the files or the processes are given a particular security classification like secret, top secret. And when the system is making an access control decision, it tries to match the clearance of the subject and object. Only if it matches, the process is allowed to execute that particular resource. If it doesn't match, means it is denied by default. So that is how mandatory access control mechanism works. And this is just a difference table between DAC and MAC. Actually, DAC enforces security by ownership, while mandatory access control MAC enforces security set by the system owner, and it will be implemented by the system. So in DAC, the user have complete access over programs, while in MAC, the files and process protection is independent of the owners. And every time ACL, access control list, will be maintained with the DAC, while in MAC, there will not be any ACLs associated. Rather than ACL, the subjects and objects will be classified according to the security clearance like secret, top secret. And DAC is predominantly used in all flavors of Windows, Linux, most flavors of Linux and Macintosh, while Mac mandatory access control systems are exhibited in SC Linux like AppArmor kind of security modules, which have been incorporated into RHEL as well as Fedora, CentOS, etc. So that's about DAC and Mac. Now we can move on to the basics of system call and how a system actually works. So when I was too young, when I started using computer, I was thinking that I'm the one who is reading a file in the computer. So it took a long time for me to understand that actually it is wrong. So it is not the user who reads the file. It is the user who runs a process, and the process reads the file for user. This picture has to be very clear. Actually, the user doesn't read any file. The process reads the file on behalf of the user. So if you are aware about this whole process, then operating system is very simple to understand. And based on this only, based on read, write, and open, we are discussing about how a Linux works, how operations are being carried out in Linux. So in the coming slides, we can see how several operations are being carried out in Linux. We'll talk about system call. As I mentioned, whenever there is a process requesting a resource, the libc has to transfer the call to kernel to execute the whole process. So in order to transfer the call from the user space to the kernel space, some mechanism has to be there. As you might be aware about interrupts and all. So there should be some mechanism to call that interrupt, right? Then only that interrupt, then only that a call will be transferred from the user space to the kernel space. So system call is such a mechanism to interact with the kernel. So it's a programmatic way in which a computer program requests a service from the kernel. So this is the only entry point. System calls are the only entry points into the kernel, as well as all programs needing resources must use a system call. So here I will explain how a read system call works. Okay, how if we are opening a file for reading, how it actually works. So for read system call to execute, actually the open system call should execute first, then only the read system call might execute. So the whole process is like when we are just double clicking a particular file, for example, a.txt. Okay, for example, we want to open a particular file named a.txt. So we will be double clicking it. So at that point, what happens? When we are double clicking it, the libc will identify that it's an open request coming. So the system want to, or the libc will understand that it's a file open that is going to happen, and it will enter into the C code for the open C code. I mean the C code for the open function. So from that C code, actually a trap will be executed, or an interrupt will be executed. As you all know, the software interrupt 80 is used to divert the call from the user space to the kernel space. So a particular interrupt will be called, and the libc will pass the call from the user space. The call is now passing on to the kernel space. Libc will pass the call with the required system call that has to be executed to the kernel space. And kernel space, there will be a system call table, system call handler, and a system call dispatcher. So when the libc calls an interrupt, the interrupt transfers the call from user space to the kernel space, and the kernel will identify the incoming system call, and it will check the system call table for the corresponding system call number that has to be executed. Each system call is associated with a particular number. So that particular number will be found out, and that particular number will be and the system call will be passed to the system call dispatcher, and the system call dispatcher processes that particular system call, and actually it sends back the handle to the user space. So that is how a file open happens, and after that file open, it's going to be a read system call. So correspondingly, a read operation and a read wrapper will be called from the C library, and correspondingly an interrupt will be called, and system call handler will identify the system call number, and it will pass the handle to the system call dispatcher, and from the dispatcher it sends back the call to the libc, and from libc the application opens and we are able to read the content. So that is the basic architecture how a system call works. And in every operating system, not only in Linux, in Windows or in Macintosh, every operating system, this is the mechanism behind the screen. Actually, what happens when we are opening a file, or when we are reading a file, or when we want to write a file. So again, the user space calls a function, suppose open. So the libc performs the system call to open. This causes an interrupt. Kernel identifies the interrupt. Kernel determines the system call being requested by reading the user space registers as well as any arguments. Arguments means the system call number will be passed, the file name will be passed, the inode of the file will be passed, everything will be read by the system call handler, and the handler passes it to system call dispatcher, and kernel transfers back the execution to where the execution occurred, means to the libc, and libc to the application. So that is basically how the system call works. We can just identify when we write a C program in Linux, what happens actually. Similar operation actually happens. So suppose, say for example, we are just writing a hello world program. I think all of you might have worked with hello world program. At least you might have written a hello world program either in Linux or in Windows. So when we write hello world, actually we will be including certain libraries, and then we will be writing the statement printf hello world or printf greetings, for example. So printf hello world. So when we compile and when we execute this file, the console has to print hello world. So for that, actually in libc, I mean in Linux, what happens is that this, when we run this file, the system will identify that a printf command is being executed. So a printf is calling a particular system call to execute the print command to print something on the screen. So for printf is actually a function, and the corresponding system call to work that function is write function. So this will be identified. So you can see here the write function. So the system call, the standard C library or the libc will identify the function, and it identifies the system call is right, and it passes this command, means the write command, I mean the write system call, as well as the arguments like hello world or greetings to the kernel space, and kernel will identify the corresponding system call number. And as the same process I said, it will find the system call dispatcher will execute this and passes the handle back to the standard C library, and from there to the program, and program prints the command like greetings or hello world to the command prompt or to the standard output console. So that is the whole screen behind how a program runs on a very high level. So I hope this is pretty much clear to everyone. So again, I'm telling, if you have any doubt, do ask. Okay. I hope I can move forward to the next slide. So coming, we are digging more deep into the security of Linux systems. So actually, what is POSIX capability, or what is capability? So capability, we can, so even if we Google, we can see about capabilities is like a token which is used to fine tune a process like that. So similarly, POSIX capability is also one of the same thing. POSIX capability is used to cut down the root privileges. As I mentioned earlier, there are some utilities which runs with pseudo privilege itself without the knowledge of the user, like ping command. Ping command actually requires a particular capability and a root privilege to execute, but it is provided with a special permission, so that we don't want to use a pseudo command in front of that. So we will discuss it. So basically, what is capability? Capability is actually used to cut down the root privileges into particular subsets of available privileges. So that is basically what capabilities is. It is used to enhance the security of the system by reducing the risk. And there are, as of now, almost like 37 to 38 capabilities defined in POSIX capabilities in Linux. And this is not a new concept, actually. This has been incorporated into Linux from the standard kernel version 2, and as of now we are using almost like 4.7 kernel version. So it's a pretty much a non pretty much non security feature, but it is not widely used. Recently, the CentOS recent release was equipped with this capability implemented, but other than that, no operating system currently use this capability. So it is the user's discretion to work out with the capability and to set particular capabilities to particular files and functions. So we'll see how it is being done and how we can set and remove the capabilities. So as I said, there is 37 to 38 capabilities as of now defined in Linux, and we can find the list of capabilities from man capability page of Linux, and this has been included in user include Linux capability.h file. So as I mentioned, the goal of this whole capability is to divide the power of root into specific privileges. So if a processor binary that is one or more capability is exploited, the potential damage caused will be limited when compared to the same process running as a root. So if a process is being abused and if the process is running as a root, then system compromise can easily happen. While if we are working with capability, that particular capability will be only compromised, and the attacker can take advantage of that particular capability only. So we can see how actually it works and why capability was introduced. So before going on to capabilities, we should understand what is the existing scenario and what caused Linux to introduce such a particular functionality. So there is a particular permission set known as SUID, which is the set UID, set on a use ID upon execution. So this SUID has been widely used, and as of now, we know recently in 2019, very big abuse have been occurred in Linux system using the ping command, since ping was executing with set UID enabled. So this set UID is a special permission which is given to particular files so that it can execute in the user space without any root privileges, but with elevated privileges. That particular function will be having an elevated privilege, but it can run on the user space itself without showing privileges. So actually this is a very dangerous strategy, as any program that has the SUID bit will be running as a root itself. So as we know, Linux is evolving in the recent times, and there are so many security concerns coming up. So there comes the advantage of using capabilities, and there comes the usage of capability actually. So we can see how this is being used and how the ping command was abused recently. This screen shows the screenshot of my computer. So here I am just checking the permissions. Before we have seen the ls command, I have explained it. So here I am using ls command to identify the permission sets of ping. And in that permission set, I can see the user is having read, write, and a special permission S. Before I explained that it should be X. That means the execute permission. Rather than execute permission, here it is set as S. Means it is a special permission that is being allocated for the user, so that this ping command can work with the all elevated privileges on behalf of the user. So this the root will be always having all the capabilities, all the 37 of 38 set of capabilities it will be having. So this ping command actually executes with all set of capabilities. So if a vulnerability is being found out for ping, then we can actually exploit that vulnerability and take over the system. So that is the issue with the SetUID permission. So we will see how we can remove that SetUID permission from ping command, and what happens if we remove it, and how we can fix it using the capabilities. So I hope this part is too very clear. Okay. So I'm moving on to show how this particular ping utility can be abused, as well as particular ping utility can be modified. So I'm just checking the I'm just changing the permissions of my ping utility. So chmod is a command which is used to change the permissions. So I have changed it to execute permission, like chmod 755. So I am giving read, write, and execute permission for the user, and just read and execute permission, for groups and others. So, and I am just running the ping command. I'm just checking the permissions of the ping command here, and you can see it is being converted to read, write, and execute rather than S. So here it is being replaced with X. So I have changed the permission, and correspondingly for users, for groups as well as others, it is being changed. Okay, and this has been changed on, this has been last used on March 10, 2017 kind of thing. Okay, so then I am trying ping command. I'm trying to ping to google.com or other IP, and you can see the socket operation is not permitted. And surprisingly, when we run sudo ping 8.8.8, it will work, because now it is having a root privilege. And without, previously it was having the elevated privilege, now it doesn't have that elevated privilege, and ping fails. Okay, so according to the man page of capability, for actually ping command, what it does is it just executes an ICMP connection to the specified IP address. So for just establishing an ICMP connection, all the 38 capabilities are not required. So according to the man page of capabilities, actually it is said that cap_net_row, this particular capability, like it is only required to establish a row and a packet socket. So it is only required to establish an ICMP connection. Then why this by default it is having an SUID, SetUID root permission with all the 38 capabilities? So that doesn't require, right? So we can just set that particular, we have taken out the SUID permission, now we can just set that particular capability. So actually this is we are checking whether any set of capabilities is being assigned using the getCap command here. So as we see, there is no capabilities is being set. So we are just setting, using the setCap command, we are just setting the capability to the ping utility. So cap_net_row, the same capability is being set to the permitted set. So a capability consists of 3 sets: permitted, inherited, as well as effective set. So again, that's a very big topic, and it need another 1 hour to describe about these 3 effective, permitted, and this inherited capability. So we will discuss it another time. So as of now, just keeping the permitted sets, means permitted capabilities, this permitted capability to the ping utility, and then we are checking the capabilities for that particular ping utility, and we can see now it is cap_net_row with the permitted capabilities. So again, we are pinging, and we can see that the ping works. So that means it doesn't require a root privilege, it doesn't require a pseudo permission, or it doesn't require any elevated privileges to run. It just requires one subset of root privilege, just one subset of root privilege. That means if a ping utility is being abused, or if it is being found out to have a buffer overflow or more subtle bug, then it can lead to a complete system takeover by exploiting the utility to invoke a shell with root privilege. And with SUID root, the ping version is overly privileged. We have to remove. And if anyone is using Linux systems, just play around with this and you will understand what is actually the risk involved with the SUID bit and what is the need of POSIX capability. So by using the POSIX capability, we are able to avoid the full root privileges, and we are able to just set the subset of a particular privilege, subset of the root privilege, a particular privilege to the ping utility, and we have helped the Linux more. So I hope it's pretty much clear, though it is confusing. I hope you might have got a at least a generic overview about what is POSIX capability and how can we play around with it. I hope we can move on to the next topic, that is Linux security module. So what is Linux security module? So security module means that a particular module that is being incorporated to a system. Exactly that it is. The Linux security module means a particular module or a particular framework is being, a kernel module is being incorporated to the Linux system. And there are officially 4 approved Linux security models such as AppArmor, SELinux, SMAC, and Tomeo Linux. And the primary uses of LSM. Why we want an extra security module when we have already capabilities, when we have already access control mechanisms pre-built in Linux? So basically, the primary use of LSM is to incorporate mandatory access control mechanism and provide a comprehensive security policy. So without LSM, without Linux security module, or without AppArmor, SELinux, Mac, or Tomeo, the default security model will be this, which I have explained in the previous slides. Okay. So we can just go on through SELinux, which is one among the security model because it is widely used. So we'll give a high-level overview on SELinux and then we can session. So SELinux is basically a Linux kernel security model. It was authored and developed by National Security Agency and Red Hat. So it was initially used for NSA's internal purpose, and later it has been released for generic purposes also. So it has been added to various of the Linux distributions such as Red Hat Enterprise Linux and OS Fedora, and all the server implementations of the Linux predominantly uses SELinux because it is much more secure with a very good policy mechanisms. And another advantage of using Linux or SELinux is that it is been incorporated into Android version since 4.3, and SELinux was available since 2005 to general public. So that is the overview of SELinux. We can just slightly just float around the the architecture of SELinux. So basically, as I mentioned, it's a Linux security model built into Linux kernel. So it is driven by a loadable policy rules. So a set of policy rules will be there, as I mentioned. The subjects and objects will be given a particular security classification. So predominantly this SELinux module, apart from the normal Linux, it has 3 extra modules known as Object Manager, Access Vector Cache, and Security Server. So what is Object Manager? An Object Manager is a mechanism when a subject requests a resource, then this Object Manager queries that if this action is actually allowed or not to the security servers. So for that, the Object Manager is being placed. Then this is the Object Manager. So an access vector cache is there in the user space as well as in the kernel space. So access vector cache basically caches, or actually it stores the access decisions already made for a particular process and an object. And security server makes the security decisions. So what happens is that when SELinux is being incorporated, then when we are making an open system call, so for example, we are opening a file, then what happens is that so when we are opening a file means it's a particular process that is going to open, and we are requesting a particular file. Okay, so here the process is a subject and the file is an object. So if a particular process requests an object or want to perform an action on a particular file or a device or a socket, then first this request is being handed over to a policy enforcement server. So this policy enforcement server, so here we can see the policy management interface. So this policy enforcement server gathers the security context, means will check what all are the permissions for the subjects as well as the objects, whether it is a security or high security or a generic one. And similarly for the security, the policy management interface will be checking the security clearance. Then actually it will this policy management interface will send it to the security server, and policy server checks the access vector cache here, whether it is already cached or not. If it is cached, then the result will be the user space itself, and the file will execute, or sometimes it may not execute, depends upon the policy. It is cached. So if it is not cached, then what happens? Then the ABC does not have the decision, means it will send to the security server itself. So the security server will check the preloaded binary policies. So there will be a preloaded set of binary policies in the security server, and that preloaded binary security policies will be matched for the subject and object, and the result will be passed on to the access vector cache, and the access ABC will cache that and send back to the user process. And if the policy permit, the access is granted. If the policy does not permit, then the access is denied. So that is the basic overview of SE Linux. And here actually the purpose of security server, this particular module is to take care of the security policy decisions, and there's an enforcement server. So the advantage or the use of enforcement server is to handle rest of all the tasks, means the object management. So that is the whole security overview of the SE Linux. And this is the basic summary. Linux is an secure open source and a free operating system, a set of operating systems. So Linux is basically secure because more people's set of security people's developers, everyone is looking into it and working on it to make it more and more secure, and it is less exploitable. So the security flows known to the information security world is predominantly less when compared to other operating systems, because as I mentioned, it is being always audited by the security people as well as the developers, and it is highly configurable. We can configure our own, and we can write our own distros, different distros as mentioned available, and Linux uses better privilege models. So that is the summary, and this is the question answer session. If you have any doubt, you can ask me.
Sir, actually, I would like to know which operating system that you are using.
Which operating system I am using? As of now, I am using Windows, but this is my office laptop. My personal laptop, I am using Ubuntu 18.04.
Okay. Thank you.
Any other question? So is there any other questions? So it's okay to wind up the session. I have seen a question. Which is the best Linux platform for hackers? It is Kali Linux. And is there any exploits in ping currently? Currently, there is an ongoing exploit in ping. That is what I was mentioning. Recently, in 2019, there was a exploit happened, and still, actually, after that release, CentOS bought the capabilities introduced for the ping command. As of now, if anyone want to exploit, they can exploit. No issues, because it's still other operating system doesn't incorporated capabilities for ping. Only CentOS has done that. So any other questions?
So the capabilities are only implemented towards not on Ubuntu or any Debian.
You are not audible actually. Mujib, you are not audible.
Hello? Right now?
No, there is some disturbance in between.
Okay, what is the situation right now?
Yeah, it's okay. It's okay. Yeah, you can ask.
Okay. I'm asking about the capabilities. It's only implemented in Red Hat or not in Ubuntu or Debian based systems?
Actually, it is not actually like not implemented or not. It's actually available in every versions of Linux distributions. Actually, it is the user or the system admin who have to make use of it. It is actually incorporated to every versions of Linux or every distro of Linux. And we have previously in previous versions of Ubuntu, and we have to actually download a particular module known as capability module. We have to download from the GitHub actually. But now it is being incorporated to all of the operating systems. And as of now, these particular capabilities are not provided by default to any utilities. It is a system admin or the system owner who have to do that. And just the CentOS latest version implements this particular capability to ping utility alone because there was an abuse in ping.
Okay. But so most probably the later versions of any operating system could be implemented.
Yeah, probably the coming versions of Ubuntu like 20 and all will make use of it probably because it is a long run concept and it is actually set up for the system owners and system administrators. Majority of the system administrators will be aware about this particular scenario actually. So it is up to the discretion of the organization as well as the user system admin to set it or not.
Okay, fine.
Yeah, any other doubts? So I hope without any doubts we can wind up this session. Is it okay?
One more question.
Yeah, please.
Is it possible to install the Windows softwares in Ubuntu?
Yeah, it is possible. We have to actually install a particular environment or a software known as Wine. So there is a particular software. We will get it from, it's an open source. It's known as Wine. You can download it and you can install it. And in that particular module, in that particular Wine, you can use Windows applications.
Okay. Thank you.
Yeah. Any other questions? So shall we wind up? Yeah, can you explain ACL?
Hello?
Yeah, please shoot.
ഞാൻ കുറച്ച് ലേറ്റ് ആയിട്ട് വന്നത് അപ്പൊ എനിക്ക് എന്താക്കി കുറച്ച് കാര്യങ്ങൾ കിട്ടാനുണ്ട് അപ്പൊ കുറച്ച് കാര്യങ്ങൾ അതിനെ കുറിച്ചുള്ള ഇപ്പൊ പറഞ്ഞതിനെ കുറിച്ച് എന്തെങ്കിലും അറിയാൻ വല്ല വകുപ്പുണ്ടോ?
I will share the PPT if you want. You can just ping me, no issues. And if you want, you can call me and ask, no issues. I'm always available to explain, no issues.
അപ്പോ ഈ കാലയളക്സാണ് ഉപണ്ടോ ഏറ്റവും കൂടുതൽ നല്ലത് വോയിസ്?
For a generic purpose, Ubuntu is good. For a development or a testing purpose or for educational purpose, Kali Linux is good. Sorry?
Metasploit ഇല്ലേ?
Yeah.
അപ്പോ നമ്മൾ ഈ മെറ്റസ്പ്ലോട്ടും എൻജിനൊക്കെ നമ്മൾ കണക്ട് ചെയ്യുന്നത് എന്തുകൊണ്ടാണ്?
Sorry, I didn't get the question.
മെറ്റസ്പ്ലോട്ട് ഫ്രെയിംവർക്കും എൻജിനൊക്കെ സൈക്കിൾ എന്തിനാണ് ബന്ധിപ്പിക്കുന്നത്?
That's a different domain actually. That doesn't directly impact the topic which I took. It's actually regarding a software or a security software running or a exploit platform. It's an exploit platform basically. Metasploit is which is used to create exploits as well as which is used for a security testing purpose. That is actually a different topic. That is not actually directly linked with the topic which I took.
Okay, thank you, sir.
Yeah, and somebody was asking about ACL, Anson M. Thomas. Is he still there? Yeah. So I will just give an overview of access control. Access control list ACL. Yeah. ACL means actually, for example, if you are a student of a particular or if you're working in a particular office, say for example you are an employee of a company known as X and it have a large number of employees like 20,000. So every 20,000 employees are being incorporated into a single office. So there will be different type of employees like CEO, system admin, the white collar employees like the IT employees, and then there will be a lot of HR and there will be a lot of employees. Okay, so and there will be security employees also. Okay, so in that case, so first we should get an ID card to enter the office. So that is the basic authentication we want, right? Only if we have an identity card, we can enter the office. And if we want to enter a particular lab or a particular ODC or a particular or a session of the office, we want that room. So there will be a biometric scanner or something like that, and we have to use our fingerprint, or we have to we want a face detection to be there to enter that particular room. So in that device, an access control list will be maintained where the authenticated users to the authorized users. Even though if you are authenticated users to enter the premises of an office, it doesn't mean that you can enter to every areas. Particular list of users means 20,000 employee list will be maintained, and in that from 20,000 a list will be maintained in every biometric meters to identify the users who are allowed to enter a particular room and who are not allowed to enter a particular room. So that is basically access control list. So in a very generic and broader sense.
So one doubt.
Yeah.
I have heard that Kali Linux is not allowed in some professional areas.
Yeah.
Can you suggest some other OS?
Okay, do one thing, download Ubuntu and download all the tools. It will be probably allowed in every organizations.
Okay.
So
I also heard about some black Ubuntu, like something like that.
Sorry?
Ubuntu.
I didn't get it. What Ubuntu?
Black Ubuntu, something like that. That's similar to Kali.
No, I'm not sure about it. I will check. Revert about that. I'm not sure about such a operating system.
Okay. Thank you.
So any other? So Black Arc Linux. Someone from the organization is asking about Black Arc Linux. Know about Black Arc Linux. It's actually a corresponding platform for penetration testing team actually. I forgot to mention about it. If someone is interested, they can try the Black Arc Linux also. See, there are varying distributions of Linux, so it is very difficult to go through all the things because there is more than 50 to 60 variants. As I mentioned, even I have developed a distribution for Linux. A lot of things which is concentrated for educational purpose as well as for enterprise purpose. So basically, we have to check the distros. Black Arc Linux is a good platform to do the penetration testing activities and all. Type of security tools. Yeah, any other questions?
Hello, sir.
Yeah.
സാർ പിന്നെ ഞാൻ എന്റെ ആൻഡ്രോയിഡിലാണ് കാലി ലിനക്സ് ഇൻസ്റ്റാൾ ചെയ്തിട്ടുള്ളത്.
സോറി,
ഹലോ, ഞാൻ എന്റെ ആൻഡ്രോയിഡിലാണ് കാലി ലിനക്സ് ഇൻസ്റ്റാൾ ചെയ്തിട്ടുള്ളത് എന്റെ ഫോണില്.
ഓക്കെ.
അതല്ല, എനിക്ക് ബ്രൗസർ നോക്കിയിട്ട് ബ്രൗസർ കിട്ടുന്നില്ല.
Which browser you are using?
അല്ല, ഞാനിപ്പോ ക്രോമാണ് ഇൻസ്റ്റാൾ ചെയ്യാൻ നോക്കിയത്. ക്രോം ഇൻസ്റ്റാൾ ചെയ്തു, പക്ഷെ ക്രോം ലോഞ്ച് ആവുന്നില്ല.
Having Chrome browser, right?
ഞാൻ ക്രോമിയം ബ്രൗസറിൽ ഇൻസ്റ്റാൾ ചെയ്ത ക്രോമിയം ബ്ലാക്ക്.
Chromium is also not working.
Hello?
Yeah, please tell.
Chromium workalla. Appo ainula command
that actually is a particular scenario, right? So I have to we have to see what is the error coming out. So just try launching it from the terminal itself. So if it is not launching, means terminal will display the error coming out. So with that error, we can see what it is. I can't predict what will be the issue.
Okay, please, sir.
Yeah. Yeah, someone have mentioned, yeah, you can try also. Yeah. Any other questions?